حازم بص لي على الرينج كنترول بيعمل ايه؟ بينقل منين لفين؟ بياخد من R3 يروح منزله فين؟ R2 يعني بياخد from 3 dimension or from 3 variables from 3 inputs وبيطلعهم how many inputs؟ 2 inputs. طيب بيعمل اللعبه الشقيه دي ازاي؟ عن طريق الترانسفورم ده الجنرال اكسبريشن. Can you get the matrix of transformation from this general expression? Yes, I can. How can we do it? By many ways. The simplest was one. How many variables here? X1, X2, X3. Please look carefully to the components. Here is R3, X1, X2, X3. And remark here is how many outputs?
2.
Just 2 outputs. Let's try the outputs, but using the 3 components. So now I have X1, am I right?
Mm-hmm.
Then negative 3 of an X2 plus, do you have X3 here?
No.
For the second component, read the second component. Do you have X1?
No.
Then plus 2 of an X2, then minus 4 of an X3. These are the 2 equations. Am I right? So the transform at the time being, or the transformation matrix, it's gonna be 1, 0, negative 3 and 2, 0 and negative 4. That's the transformation matrix. Let's see. The transformation matrix. What do you know about the linear transformation? If I multiply the transformation matrix by the n matrix, what's the n matrix? X1, X2, X3. The result will be the general expression. Let's do it. Let's check. Try to multiply. If I multiply the first row by X1, X2, X3, it will give you X1 minus 3X2. Okay, if I multiply the second row by them, so it will give you 2 of an X2 minus 4X3. And that's the 2 components. Let's do the ranks. The dimensions. It is 2 by 3. And this is 3 by 1. So the result should be 2 by 1, as you can see. Now check. The first component in the general expression is okay. The second component in the general expression is okay. So that's the general transformation. I have now the transformation matrix. Is it difficult? No. First of all, look at those 3 components. That's R3. That's R3. Then, using the transform, it will be moved into R2. Okay? معايا حازم؟ برضه بتنام؟ ده بتهرج. خلاص يا شباب؟ Okay, perfect. So, once more, given the general expression that defines this linear transformation, here is the general expression. Remark, this is the transform في الحته دي بتبقى في ازاي؟ شد من رجلك. Okay? Transform يساوي AT times X. Step اللي بعديه محمد بص, this is the vector. I've wrote it in a matrix form. It's gonna be easier on you, which is very, very simple. It's A times X1, X2, X3. I'm searching for this guy. Okay, how to search for this guy? I will start by writing this one, but as an equation, considering which components does not exist. X1 exists, negative 3 X2 exists, 0 X3, because I don't have X3 in the first component. In the second component, that's 0, 2, and the negative 4. So it's really very simple to get A, which is 1, negative 3, and 0. The second row is 0, 2, minus 4, as you can see. And we can check the multiplication. It's going to be already exactly as the general expression. Okay. Notice also, there is another way, we will see it in the coming slide, to get, just a sec, less than a second, please. I can get also the transformation matrix from the columns of the identity matrix relative to Rn. يا حازم. I can get the transformation matrix. أقدر أجيب transformation matrix from the columns of the identity matrix relative to Rn, to the input. هنا الانبوت بكام يا شباب؟ الانبوت R3. لذلك هروح اكتب الاليمنتس بتاعت identity matrix of third type. Identity matrix that contains 3 by 3. What are the columns?
R1 negative.
The second column, third one. معايا مستر حازم؟ معايا مستر محمد؟ Let's use the first column. خد الفيرست column حطه هنا. بص ايه اللي يحصل. لو انا استخدمت الفيرست column وبدات اعمل فيه substitutions. عمر substitute with me. 1 minus 3 times 0. So the first component is 1. The second component has, this is going to be 0 minus 0. So the second component is 0. Let me write it here. This is 1 and 0. Okay. I'm going for the second column. I will take the second column and I will make a substitution. x1 is equal to 0, x2 is positive 1, x3 is equal to 0. Let's substitute. x1 is equal to 0, but x2 is equal to 1. So that's going to be negative 3. Then taking these values and substitute here also. So it's going to be 1 and 0. So it's going to come up to 2. That's the second column of the transformation matrix. Then I will use Hazen, the last column. Exactly the same, make a substitution. So I will substitute by these values in the 3 components. So x1 is equal to 0, x2 is equal to 0. So the first component is, last component or second component is going to equal to negative 4. So actually, this is the transformation matrix that you are seeking, which is 1, 0, negative 3 and 2, 0 and the negative 4. That's the transformation matrix. Let's check what we have done, what we have done right now. So in order to get the transformation matrix, you can do it by 2 ways. You can do it by 2 ways. The first of them is to say x1, x2, x3, which is relative to the general expression. Okay, very good. I understand the linear transform. So I'm going to search for, yeah, Omar. I will start writing x1, x2, x3, x1, x2, x3, putting the coefficients, which is 1, negative 3, and 0. For the second component, exactly the same. Now I have the transformation matrix, which, as you can see, here it is. I can do it, look at this one, look at the transformation. I can do it in another way. So it's already correct. I will use the columns of the identity matrix, but relative to the input. How many inputs do you have? How many components do you have? 3. So get the columns of a 3 by 3 identity matrix, which are 1, 0, 0, 0, 1, 0, 0, 0, 1. And to substitute each vector of these columns into the general expression. You will have one column, a column by column. Okay? معايا حازم؟ once more. T of 1, 0, 0. That 1 and 0. Which is the first column. Try to substitute by 0, 1 and 0. It's giving you the second column. Multiply, I'll start substituting by 0, 0 and 1. It gives you the third column. So I can now get the transformation matrix that I want in anyhow from any transformation once I have the general solution. Or I have the general expression. Are you with me? So if I give you the general expression, you can easily get the transformation matrix. This is very important. Okay, done. That's the transformation matrix that we are seeing. Propositions, which is really important. The questions usually targeting these propositions and so on. If T is such that moving from Rn into Rm, so moving stuff from Rn to Rm, is a linear transformation. The following conditions hold. The following conditions must exist. This is the meaning of a linear transform. Maybe there is a non-linear transform, or there is other types of transforms. But the linear transform should do the following, يا عمر. Number one, it protects the addition. So transforming the addition of two vectors, it's equal to the transform of the first vector plus the second vector. Do you read me, Hazard? Once more, I will repeat it once more. هنا أنا بعمل transform لمجموع two vectors. بعمل transform لمجموعة how many vectors؟ two vectors. ألاقيه بيساوي الترانسفورم بتاع الفيكتور الأولاني زائد الترانسفورم بتاع الفيكتور الثاني. ده كونديشن عشان يبقى لينير ترانسفورم. كمان حاجة، لو أنا ضربت some value في الان فيكتور يساوي بالظبط السيم فاليو دي لا في افتر ترانسفورم. Which means k times u is equal to k times the transform of u, considering k belongs to r for every u belongs to rn. يعني linear transformation بيحافظ على الاديشن between vectors وبيحافظ على المالتيبليكيشن in a scalar. معايا حازم؟ اوكي فيري جود. برضه كمان حاجه انه اللينير ترانسفورم لو انا بنقل الزيرو من ار ان هيروح يسمع في الزيرو بتاع الار ان. لو بنقل الزيرو بتاع ار ان يسمع في الزيرو بتاع ار ان. تعال بص كده. ده ترانسفورم اهو. تعال نقل لي 0 0 0. ما هو 0 0 0 ده الزيرو بتاع ار ان. لما تيجي تنقله هتنقل في الزيرو بتاع ار ان. انقل 0 0 0. لما تيجي تعمل سبستيتيوشن يديك 0 0. صح؟ يبقى إذا moving even the origin as you can see. Linear transformation main conditions very important to remember. These two conditions or three conditions very very important. Okay? Done. We can also write any transform as the following, but this is not related to the transforms. I want to show you this game. This is A which multiplied in x1, x2, x3. Guys, look at this. If I have a matrix contains 3, 2, and 4. Can you see this column matrix? I can write this column matrix as a sum of elements multiplied يا حازم in columns of a unit matrix. Okay, بص كده يا عمر. This matrix is equal to 3, 0, and 0. Am I right? Plus انت بتقول اه خلاص بتزيد يلا صح؟ 0 to 0 plus 0, 0, and 4. Am I right? Is it possible?
Yes, possible.
فكر. انا عندي دي ماتريكس 3 و 2 4. انا فكيتها لماتريكس 3 دبل زيروز وماتريكس ثانيه 3 2 0 ماتريكس ثالثه 3 0 0 0 4. Are we correct? I can also do it this way. I can say that this is 3 1 0 and 0. Am I right?
Yeah.
And this is 2 which is 0 1 and 0. Am I right? And this is also plus a 4 times 0 0 and 1. Those are the columns of a unit matrix from the dimension of the Rn. Okay, شباب? يبقى إذا I can do that. And to also, this is just only for the column matrix. So for the main transform, which moves A times x1, x2 up to xn, I can rewrite it this way. AT, which is the general transformation matrix, times x1, the column of the unit matrix, x2, the column of unit matrix, xn to the column of a unit matrix. Which means I can do it this way. x1, which is a constant, can be taken outside, multiplying A by 1, 0, 0, A by 0, 1, 0, and so on. This is the general transform. A linear transformation, T from Rn into Rm, is completely determined by the images of the column of the identity matrix In. Remark, this is In, which is relative to the Rn. And this is what we did in the previous problem. Okay? We completely defined the unit matrix by the columns of an identity matrix relative to in the input. Okay, I will do it with you. See, that's the definition. Okay, do you remember this problem? That's the previous problem. We have x1, x2, x3. I can find the transformation matrix because the transformation matrix will be the images of the unit matrix, which is I3. This is what I did. Once more, transform of 1, 0, 0, 1, 0, 0, it will be 1 and 0. The transform of the second column, 0, 1, 0, it will be negative 3 and 2. The transform of 0, 0, 1, which is going to be 0 and negative 4. And that's the main transformation matrix. So everything makes sense. Perfect. Now I can go between how to write the general expression, how to get the general expression, either from the identity matrix or the general transform. Of course, it is written to you as you saw from that previous slide. This is once more stating that I can get the linear transformation matrix from the columns of the in matrix as you saw. That's another problem. Consider R3 into R3. This transform is moving stuff from R3 into R3. How the transform is going to work? It's going to make the following: switching and multiplying. So each element XYZ will be moved into R3, but it will be moved in another shape. It will be 2, 1 and negative 1. How to do it? I can get the transformation matrix. How can you get the transformation matrix like this? I will use 1, 0, 0. Here's the transformation matrix. I can evaluate it very quick. I will use 1, 0, 0. So if I use 1, 0 and 0, let's do it together. The Y will be, the X will be, the Z will be. So the image of 1, 0, 0 will be, I will do it once more for the second column of the transformation matrix. Let's do it once more for the transformation matrix. I'll use the second column, which is 0, 1, and 0. Let's do it. So it's gonna be a 1, then a 0, then a 0. So it's gonna come up to 2 times 1, which is gonna be
2.
Then the other 2 elements will be
0.
I can do it once more for the third column, which is 0, 0, and 1. And this will result 2 times 0, 0, negative 1. So it's going to come up to 0, 0, and negative 1. That's the transformation matrix. Mr. Hazard, I can do it by another way. How to do it in another way? Those are x, y, and z. So I will start 0 at the time of x. And for y, I'm writing the first row. Okay? So I'm writing the first row. So it's a 0, a 2 in y, and I don't have z. Do you have z's here? First component. Do you have x? انتوا مش معايا يا جماعة. And I'm talking about this is the first component. You should see x, y, and z. Do you see x, y, and z?
No.
يبقى 0 times x plus 2 times y plus 0 times z. Let's move to the second component. That's the second component. Does it contain x?
Oh.
Yes. Do you see y or z?
No.
0y plus 0z. Let's go to the third component. This is third component. Does it have an x? 0 and x. Does it have an y? 0 and y. Does it have an z? It's a negative z. Remove x, y, and z to get the coefficient matrix. The coefficient matrix will be 0, 2, 0. First row. The second row will be 1, double, 0. The third row will be 0, 0, and the negative 1. Exactly the same. So I can get the transformation matrix either from the columns of the identity matrix relative to the input. And also I can write it row by row from remarking the input values and the output values as equations. Are you with me? معايا حازم? Still sleeping? Okay. Here we go. This is when I use 1 0 0, this is 0 1 0, this is 0 0 1, and that's the transformation matrix using the columns of the identity matrix. Okay, once more from R3 into R3, 2y x minus z. I can write them using the t's, and that's the transformation matrix. I can write them separate from each other. That's x times the transformation matrix, that's 1 0 0. And also that's the transformation matrix 0 1 0 times y, and the z same way like. For notice that for this example, this is of course a linear transform, because if I have for 2 4 and negative 6, I can easily write 2 4 minus 6 as this is the transformation matrix times 2 4 and 6. What's that, Muhammad? The result will be 8 2 and 6. I think it's really very simple to take 2 as a common from this matrix.
Oh.
If I took 2 as an example, as a common from this matrix, it's going to be 2 times 4 1 3. It's really very easy to find 4 1 3 as an image. What's the object that can be used where its image is 4 1 3? If I did that, you will find that the image is simply, okay, is simply going to be 1 2 and the negative 3. So if I used 1 2 3 here, 1 2 3, okay, multiplied by 2, the image will be the same. So, and this proves the first relation of, this proves this relation. Okay, if I want to explain the addition process, I can, after transform, instead of having 8 2 6, I can explain this vector as a sum of any other 2 vectors. And for example, I can do 8 0 6 plus 8 plus 0 2 0. It's just an example that instead of having one column matrix, I've separated them in any 2 matrices. Okay, and I can get the n matrix for this image and the n matrix for that image, and also this is once more getting the n matrices. So the transform of 2 0 0 0 4 and negative 6, it will appear into 0 2 0 8 0 6. Once you add them together, they will be equal to each other, which means we have the transform correct. The addition of 2 vectors equal to their addition of their transforms. The multiplication of a constant before transform, it's equal to the value of the same value of constant after the transform. Also, for this transform, if I moved 0 0 0, it will be mapped also in the origin of the images. So if you try to put the 0 column in n dimension, it will appear into 0 in the output or in the images. Okay, that's also another way to reinforce the same idea, same problem previously, and also explaining the 2 issue or the multiplication by a constant or the addition of 2 vectors. I think I will need to continue with this slide, but I will make it a recap next time. Okay?
Yeah.
Thank you very much for today. I hope you enjoyed this lecture. This is really very important lecture. So please try to go through it step by step. Thank you very much. I appreciate it. And I will see you next time, inshallah. Thank you.